A very good morning to everyone. Welcome in today's class, and today we are going to talk about K and R selected species. That is the topic of today, and it comes under the heading of types of selection under population ecology. But before beginning with the class, let's have a small introduction about Unacademy. Unacademy is one of the India's largest platform for the preparation of CSIR-UGC NET, and you are seeing this video on the channel Let's Crack CSIR-UGC NET. A small introduction about myself. I'm Farida Bandookwala. I have a teaching experience of 10 years. I'm pursuing PhD from School of Biotechnology, DAVV, Indore. If you are opting Unacademy, what all things you people are going to get, let us talk about that. You will be getting daily life classes, you'll be getting structured courses, you'll be getting live tests and quizzes and unlimited access towards the videos for which you are opting. So daily life classes is going to keep you motivated. Structure course is very important because the 13 units in CSIR, they are very lengthy, and if you are not reading it in a systematic manner, it can be very tedious and bulky for you to study. Live tests and quizzes are important because you need to evaluate yourself that how much you have learned so far, and that is possible only when you are opting for live tests and quizzes, right? After that, I'll tell you about the free live classes. Unacademy gives free classes on YouTube platform and special platform. These are the two platforms where the classes are completely free. So YouTube classes, you are watching one of the YouTube free live class over here. So that is the YouTube free live class, and in special classes, you get to see the special classes when you download the Unacademy learning app from Play Store. Then you need to make your account over there and opt for a particular course for which you have to prepare, or for a particular examination. In terms of my class, you need to opt for CSIR-UGC NET, and then you will get the access towards all the special classes. If you want to follow a particular profile of an educator, and you need to watch all the videos and you need to get the notification of all the videos that particular educator is doing, just follow the profile of that educator, right? So these are the two places where you can get the free live classes. YouTube, you can watch simply by going to YouTube and subscribing that particular channel. For special class, you need to download the app. After that, there is another platform, that is Plus platform. This is a paid platform, and believe me, all the 13 units are present over here in a well structured manner, so you can qualify the examination very easily by using the facility of Plus subscription. The faculty members who teach at Plus subscription and Unacademy platform, they are highly eminent, and they can guide you very well to qualify the examination. And the another thing about this Plus is the classes are live. So what is the benefit of live class? That you can ask your doubts and queries directly with the faculty member. After that, there are subscriptions which are available for a month, 3 months, 6 months, 12 months, and 24 months. Recently, a major discount is going on, that is 54% in 12 months and 67% in 24 months. So just opt for 12 months or 24 months. Maybe if you are the final year student or final semester student, no worries, just go for this, because in the end you need to make your career in the same field, so you have to study overall the life science topics. So just opt for this, and it is very pocket friendly. You can easily afford it. After that, if you're using my referral code, you'll be getting a 10% discount. My referral code is FB01. So just by using my referral code, again the prices are going to come down, and just go for it, right? So after this, quickly we'll move towards the topic of today, that is K selected species and R selected species, right? So we'll write over here K selected species and R selected species. right? So before actually jumping to the K selected species and R selected species, what we'll do is we will talk a little about the population growth and population growth curve so that you people will be able to understand. So first of all, we know that what is population growth. Population growth. This population growth is actually represented by dn by dt. And population growth can also be called as growth rate. This formula is also for growth rate. What is growth rate? That if environment and that particular habitat supports the growth of an organism, the number of organisms which can increase is called as growth rate. That this growth rate is in terms of individuals of a particular species. Right, this we have seen in yesterday's class also. Those who were attending yesterday's class was on succession. Day before yesterday's class was on this topic, that is your Lotka-Volterra model. In that we have seen this quite well, that how the growth rate is affected when more than one species is present, right? So dn by dt, that is the growth rate. Now this growth rate is one thing. Another thing is rise in a population, that how the population is going to rise or what will be the rise in population. So better, what is rise in a population? So rise in a population. So rise in population is like this, that is, it is represented by R. R is equal to B minus D. So this is the rise, R. B, rise. B is for birth and D is for death. So rise in population is equal to P minus D, right? So rise in population and population growth, these are the two things. So population growth and rise in population. So growth rate is actually given by another formula, that is the club of the two. So growth rate is equal to, that is dn by dt equals to R into N. Now what is N? We have already seen in previous classes that this N is number of individuals in a population. Number of individuals in a population. So growth rate is dn by dt equal to R into N. R is the rise, N is the number of individuals in a population. Right. If the R is increasing, that means that birth rate is more than the death rate. We'll take another color. So if B is greater than D, if B is greater than D, the R is going to increase. R is going to increase. If B is less than D, R is going to decrease. The growth rate is going to decrease. Now, in this formula, if R is increasing, like for example, a species is localizing a particular area and succession is occurring and there is lots of potential in that particular habitat, what will happen? The growth rate will be exponential. Exponentially, it is going to rise. So if it is exponentially rising, that means there will be positive growth. And if we are talking about the positive growth and exponential growth, which is not at all obstructed by environmental factor, we are going to get a exponential graph, right? So this is the exponential graph, and this exponential graph is for R, exponential graph. exponential growth, we'll say when we are talking about this. And on y-axis, what are we taking? We are taking number of individuals. Number of individuals. So this is the y-axis and this is the x-axis. On x-axis, we are taking the time lapse. Right? So number of individuals are going to exponentially rise if there is no obstruction from the limiting environmental factors. If the environmental factors are more than enough, it is going to increase in the positive direction. But that is not the case always. The resources are limited. There is a certain carrying capacity of a particular environment that should be kept in mind. So the another term that we need to know over here is carrying capacity. Carrying capacity. Now, this carrying capacity, how is it going to affect the growth rate? Right? So carrying capacity, what all factors are going to play its role when we are talking about carrying capacity? The neighboring species or the species which are dwelling together in that particular environment, they are going to play the major role. Then the limited food resources, limited shelter, then temperature, moisture, all these things are going to play major role in carrying capacity. So instead of exponentially increasing, there will be a plateau that it means the habitat, it can support only a limited number of individuals, and when the limited number of individuals has reached or the number of individuals have reached that particular limit, the growth will become stable. That the number of individuals dying and number of individuals taking birth are stable. So if we are drawing a curve like this for the carrying capacity is also playing the major role, the graph is going to be like this. Now this is the place where it is showing us that environment is having limited capacity. So on y-axis we are going to write number of individuals, and on x-axis we are going to write time. So same like that. And when we are looking at such kind of curves, they are actually logistic curves. Logistic curve. Right, logistic curve or logistic growth, which is more realistic actually. Which is more realistic. Right, so carrying capacity is actually, I don't know why this is. So carrying capacity is denoted by R. And here we were talking about the rise in population. It is denoted by R. So we will just highlight these two things. So this is the graph for K, that is the carrying capacity, and this is the graph for rise in population. You could write over here. Rise in population. Right? So rise in population is going to give you an exponential curve, and carrying capacity is going to give us a sigmoid curve. So these are the two things that you should keep in mind. When you have seen these two things, you need to see the R selected species and K selected species. R selected and K selected. So basics we have done. Now we'll move towards the actual thing. So when we are talking about R selected species and we are talking about K selected species, we need to see various factors. Those all theoretical part also we are going to talk just now. But before that, what is R selected and what is K selected, and it is dependent on what? So this R selected is dependent on growth rate, completely on growth rate. Growth rate of a particular species. If a species has maximum potential of growth rate, no worries. It is going to increase and increase. When we are going to talk about K selected species, it is dependent on carrying capacity of the environment. Carrying capacity. So remember only these two things in your mind and you will be able to attempt the questions, right? So these are the things which you should keep in mind. Now there is a new formula for the growth rate when we have seen R and K selected. So growth rate in terms of carrying capacity, we get a new formula, that is R, rise in population, into number of individuals in that population to the power k minus n upon k. So this is the new formula that we get after studying all this. So this is all calculation and what to say, the mathematical part we have seen. Now we'll be moving towards the theoretical part of the K selected and R selected species, right? So let us write over here K selected and R selected. Now, whenever we are talking about a species, each species, whichever species we are talking about, has a specific mode of reproduction, right? They cannot increase their number without reproduction. So, each species has a specific mode of reproduction. Mode of reproduction. There are various species whose basic aim is to reproduce. Just what they'll do is they will reproduce. So some species, their major aim of life is reproduction, and some species, they have some other goals as well. Goals in terms of what, that they reach their sexual maturity after a certain point of time. And certain species, they reach their sexual maturity as soon as they spend some days or some time on the life. As soon as they are born, they reach sexual maturity. So the reproduction is the major thing because they are achieving it quite early as opposite to the humans who achieve it later. So that is the secondary thing. So they have many offsprings. The individuals or the species whose major aim is reproduction, or the species who reach the sexual maturity, the number of offspring they produce is many. In a single cycle of reproduction, they produce many offsprings. They reproduce and reach the reproductive age very rapidly, right? And when they reach the reproductive age very rapidly, they have a very short generation time. Their offsprings are going to be more, but they are going to give very little time for making the offspring. So first condition is certain species reach sexual maturity at quite early. So those species who are reaching the sexual maturity at quite early, what all things we are going to see? They have short generation time. Their offspring remain with them for a very little span of time. I told you, for making the offspring also, they take lesser time. So, and the time they spend with their individual is also very less. So, less parental care or protection. They provide very less protection to the individuals, right? So these are some of the things which we need to see. And there are many species who reach the sexual maturity later, and they spend lot of time with their offspring. That is, parental care is shown, parental care is exhibited. right? So species with such a capacity of showing less parental care and producing lots of species fall under the category of R selected species. And the examples of R selected species can be algae, bacteria, rodents, then some of the annual plants, insects, etc. And they tend to be more opportunist, that if the environment is good, they will rapidly increase in the number. Now they reproduce and disperse rapidly also, like we see rodents, they are dispersed everywhere and they can survive in lot many conditions. After that, the sexual maturity, which is reached later in life, they are called as K-selected species. These species put very little energy in reproduction. They reach the sexual maturity quite later in their life, and they tend to reproduce quite later in their life. After a certain years, they reproduce. So they have fewer offsprings, they spend lot of time with their offspring, they show lots of parental care, they spend lots of energy in upbringing of the offspring, and the example is humans, right? So these are the two things which we have seen. Now we need to see them systematically, that what all features are included in K selected species and R selected species. So features, we would write features, and when we have written features, first of all we will see K selected species. So K selected species, we know that K selected species, what is the major example of K selected species? Humans. So what type of environment is needed for the growth of K selected species? It cannot be highly unpredictable. It cannot be changing over and over again, because that won't be good for the newborn individual. Though the adults, they are sturdy, they are more strong, but the individuals, they are quite uh, sensitive or fragile. So the environment should be constant, and if it is not constant, like certain places it observes lots of rainfall and high snowfall, so that is coming under the category of predictable. So it should be constant or it should be predictable. It should not be extreme, it should not be unpredictable, right? So the environment should be constant and predictable. Constant and predictable environment. When we are talking about the survivorship curve. So survivorship curve, we need to see the curve also, that what curve we need to make for K selected species and for R selected species. So we will see that. So when we are talking about the survivorship curve, we need to see that curve. So when we are talking about the K selected species, the curve would be convex. The survivorship curve is convex. So on y-axis and x-axis, what are we drawing? On y-axis, we are drawing number of survivors, and on x-axis, we are drawing percentage of maximum lifespan. Percentage of maximum lifespan. So the survivorship curve for the K-selected species is convex. Remember this, that the survivorship curve for K-selected species is convex. Then the death rate is less, density would be constant, or near to the carrying capacity. It is dependent on the carrying capacity, because we are calling them K-selected, so that is the representation of carrying capacity. So density is fairly constant, number of individuals constant. After that, individual characteristic, if we are going to see, so they have large body size. Their body is large body. Then their dispersal or their area of dominance or where they are living, that will be quite less. Poor dispersal power. The places which they are occupying would be quite less. After that, they have high level of social organization. High level of social organization. High level of social organization. So high level of social organization is even seen in honeybees, but they do not fall in case-selected species. So high level of social organization, that is, there will be division of labor in a very systematic manner, right? So these all we have seen that what are the features of case-selected species. Then let us talk about R selected species. R selected species. So our selected species, we need to see the environment. Environment can be variable, can be unpredictable, can be unpredictable, like cockroaches. They live in the drain, they live in the very moist and dark places. They can live in on the normal floor. They can live in the highly moist, watery floor of washroom. They can live in the drains. They can live in the open area. They can live in the small corners. So the environment can be variable or unpredictable. Now talking about the curve, that is the survivorship curve for the R selected species, the survivorship curve would be different as compared to when we are talking about the curve for the case selected species. So are you going to guess what kind of curve we are going to get? So first of all, we'll write that there we were getting the convex curve. Here we are going to get the concave curve. Now, if we are going to get the concave curve, how is it going to be? So the concave curve for the R selected species would be like this. The curve is concave and there is lots of death in the individual as compared to the K selected species. Here also the y-axis and x-axis tells the same. So y-axis, it was telling us about the number of survivors, and x-axis was telling about the percentage of maximum lifespan. So the same thing, I'll write once again, the number of survivors and percentage of maximum lifespan. So this is the curve for our selected species. Fourth, the density is variable. It can be more, it can be below the carrying capacity or it can be with the carrying capacity, because it is not following morely the carrying capacity. So it is not largely dependent on the carrying capacity, right? So density constant for our selected species. Now the individual characteristics can be small body size. The body size would be small body. Then the dispersal would be large. They are present almost everywhere. Large dispersal. Then low level of social organization. Low level of social organization. Right? So this is how we have seen case selected and R selected species in detail. I can see some of the students who are listening the class live. Please write in the comment box if you people have understood what I have explained you in the class. Please write in the comment box that what I have explained you. Are you people able to understand? Yes or no? Have you understood? Yes or no? I can see certain students who are watching the class live. So I'll just revise in a minute. So first of all, we have seen the growth rate, then we have seen the rise in population, which is represented by R, then we have seen the growth rate, then we have seen the carrying capacity, and then we have seen rise in population and carrying capacity, two different graphs, which are the representation of R and K selection. After that, we have seen the individual characteristics of K selected and R selected species. We have seen the curves. Remember the curves in your mind so that you will be able to attempt the questions in the examination. So like this, we have completed the R selected and K selected species. If you people haven't subscribed the channel, please subscribe the channel. Let's crack CSIR-UGC NET, and hit the bell icon for getting the notification for all the upcoming videos. And if you really liked my video and you have gained something, or you have enjoyed watching the concept of this population ecology, please give it a like. It will really motivate me. And if you are going for plus subscription, which can be highly beneficial for you, so use my referral code FB01. Do not forget to use my referral code, that is FB01, and get a additional 10% discount, because the discount is going on. So more discount you'll be getting by using my referral code. So just go for this plus subscription. And lastly, thank you very much for your patient listening. Come back tomorrow. We'll be discussing some more important topic of ecology. And this month we are doing ecology. So you can write in the comment box what topics you want to study, what all things you want me to explain to you. This is it for now. We'll be meeting again tomorrow 11:30. I have a class, so just come back for a class tomorrow. I really was looking forward for your reply in the comment box, that whether you people have understood or not. But it's okay. Thank you very much. It's bye for now. We'll be meeting tomorrow with another topic of ecology. I can see some people have joined the class now again later. So sorry to say the class is over. The live class is over for now. Just watch the recorded session of K selected and R selected species. It is one of the most important topic which is usually asked in the examination. So